So I have been having a problem with my water pump. I have a shallow well jet pump in the basement shown here, and lately it has been running well over the cutoff point, the high point of 60 psi. It should shut off, and it's been running beyond that, 65, 68 psi, and sometimes hanging there and just continuing to run until I get down to the basement and shut it off. So I finally had some time today to dig into that, and I think I've got that problem resolved. But before we get into that, for all of you plumbers out there, based on the image you see here, you can tell clearly I'm not a plumber, but just take a minute and marvel at this. So before I started tearing things apart, I went to the computer where I usually start my investigation and came up with this search term. It sort of prompted me in the right direction. And I did go down and check the pressure in the tank, and it was reading correctly, and there was no moisture coming out of the air bladder in my pressure tank. So that was the first step. However, I'm glad because those are expensive and that would be complex to change. But that wasn't the problem that I was dealing with. And my next step was here. You can see this is, obviously PVC pipe. There are two union fittings, one above and one below PVC check valve. This is my supply line coming out of the ground and what goes into my tank. So I put a check valve in there to help maintain the readiness of the water when the pump would come on and not have it need to draw so far and help keep the pump primed. Anyway, I reduced the pressure in the system and I took these unions apart, and I was glad to see that this PVC valve was still functional. It didn't look like there was any signs of trouble here. It didn't leak at all. It was working just fine. And for those interested in considering this in one of their systems, this has been in place for more than 10 years. And then I moved over to look at the controller, the PUMPTROL, the Square D PUMPTROL motor controller, and took the cover off that. I'm just showing you here in case you've got the same model or one similar. In this image, you'll notice there are two springs with adjustment screws, a large spring farther from us and a narrower spring that's closer to the camera. And those are for adjusting the command on and command off for the motor according to the pressure in the tank. And you all may find better answers on the internet. Going from memory, I think the small spring drives the distance between the low pressure on and the high pressure cut out. So let's say 40 to 60 psi. That small spring would adjust that spread to be a 20 psi differential. I believe that's right. And the large spring will drive that, the 40 on, 60 off, up and down the scale. So you could move it down to come on at 30 and go off at 50 or 35 to 55, etc. I think that's how it is. Better look somewhere else for the real information, though. But up until today, this is where I did all of my fiddling on the system. I was really thinking I had a bad controller. So I adjusted the screws. I tinkered with that. When the pump was running and I could catch it, I'd go down to the basement and look at this. And I'd put a deep well socket on those nuts, adjustment nuts, and I'd play with those and the manual on and off lever, which is on the back side of the controller from here. But this is where I focused all of my effort when the pump was operating. I would say unsuccessfully. I was able to manually turn it off, which was good, but I made no progress on resolving the fact that this pump would continue to run beyond the set point of 60 psi, sometimes to shut off at 65 to 68 as I suggested, but sometimes it would run continuously until I came down and turned it off. And it's a full duty cycle motor. I wasn't worried about the motor burning up, but the pump to sit there and run and cavitate and churn water over and over, that's not a great situation. So this is a mechanically actuated relay, I guess rather than an electrically actuated relay, but power comes in on the top two terminals. One's line and one's load to the motor, and then on the bottom two terminals is the neutral, and I guess you'd call it neutral from the load and neutral back to the line circuit. So just to explain how that works, there's a plastic paddle that operates two metallic and conductive bridges across each of those terminals. So, and that is operated by pressure coming out of the tank. So electrically, all of the wires, come from the outlet in the house or the circuit in the house. They go through this switch, and then they go into that motor mounted on the side. You can see the jam nut and the conduit on the bottom of the picture. That goes, so the power comes in through this switch into the motor. The pressure to operate this, you see that copper pipe. I just wanted to point that out to you. There's a small copper tube. It looks like a water line to your refrigerator, for example. And that runs from the pump housing, and beneath this bracket, it runs into an elbow fitting which comes up underneath all of these springs. And I believe there's a diaphragm or some sort of lever that will help manipulate this switch. I think if there's an over-center device, and the pressure trips it, and it resets when the pressure falls back down. So I just wanted to show the input of that copper pipe, and this is where I started taking a closer look. As you can tell in these pictures, look at the water everywhere. It went all over the wall, my refrigerator, all over me. I had about 3 seconds of adiabatic isentropic psychrometry. So you engineers will know what I mean. I had about 3 seconds of just being saturated in a stream of water before I decided to do something different. And how that happened, I investigated this copper pipe, and I began by removing the brass coupler nuts. Started on the side on the right, which goes into the pump housing, and I worked that loose, and then there's a compression ball on the end of that pipe, and I by hand broke that free, and I noticed no water dripped out of that. So that was helpful for me. That it's not what you want to see, but it told me that this is probably the reason we have a problem. So no water pressure was getting into that line to feed the pump controller. So after removing that, I removed the same brass nut on the left side near that elbow, and I took the line back and blew air through it, and some debris came free, but not a lot. There was something in there, but not enough to be a problem. So I blew that line clear, and then I focused on that remaining brass nut where you can see all of the new Teflon tape in the pump housing. So then I put I tried fitting a wrench on there. It's pretty close to the casting, so I was able to get it free with a long or a deep well socket and a wrench. And I started backing that brass fitting reducer out of the pump casing. And this is where it got funny. So in my mind, I was going to slowly back that out and see water either start to leak or not leak, and make my next decision from there. Well, what I should have done was drained the system. I still had about 55 pounds of pressure in there, again, no water leaking with that copper pipe removed. But once I started breaking that reducer fitting free, I got a couple turns on it, and water started to come out before I could make any other decision. All of the water came out, and it blasted that fitting away and behind my refrigerator. I had to go find it, and water was everywhere, and that's when I was in that 3 seconds of panic, just being covered. And thankfully, I made one smart decision and unplugged the pump before I was investigating this. This is all on the back side, so I'm leaning over everything, and I had the protective cover off of my PUMPTROL unit, so what I showed you earlier, all those electrical connections were wide open and in the stream. So yeah, really good. Have it unplugged before you start introducing the risk of water. And that fitting, once I found it, was just completely full of debris, rust, or minerals. And I had to take a small tool and probe it out, punch all of that debris out, and clean it up. And I guess one good thing of having the system pressurized, once I broke it free, all of the blasting water gives me hope, purged out any other debris in the pump housing, came out that hole and cleared that up. So I put the new fitting cleaned up with Teflon tape back into the pump housing that you see there. And then I reinstalled the copper pipe with those brass nuts. No Teflon tape on those. Those are compression fittings. So put those back in place, and I made a last look on all the other fittings and the PVC union couplings that I had played with earlier, and those were tight. And then you'll see in this picture, I find it comical. I'm working in plumbing and I needed a hair dryer. And so I asked my son to please go fetch me a hair dryer because there was, again, water all over the electrical connection. And before I re-energized it and plugged it into power, I just wanted to dry that all off. So that took a few minutes. And once I was satisfied with that, I put the cover back on and reconnected power. In my case, I just plug it in. I've got an outlet nearby and I plug it into that. And then that lever that I showed you earlier here in the top left of the picture, you've got to hold that on manually until, in my case, you get about 30 pounds of pressure in the system. And from there, the controller will take over and you can go hands off and it will run automatic from there. And I cycled this with water usage in the house. I cycled this several times and it's right within range. I think it comes on a little bit early, 41 pounds, and shuts off around 60 pounds. So those 2 screws I showed you earlier, I could spend more time and adjust that to get it right on. I may do that only so that I know if it's right at 40 on and right at 60 off. If I just know that it's right there, I'll be able to monitor it if it starts to drift. But otherwise, it's running great. And I'm glad I found the problem. Was unsure if I had a bad check valve or some other problem with my well, and maybe a bad pump controller, but it just turned out to be this one copper line, and more precisely that fitting feeding it was clogged. So hopefully this helps you all if you have a similar issue. There's a lot of content out on the internet, but I didn't see any recommendations for looking at this. And there was no charge. It didn't cost me any money. It cost me a little pride, but I didn't buy a new controller or a new motor or any of that. Or maybe while I should have, I didn't need to call a plumber. So just a little embarrassment that I'm happy to advertise on YouTube, and hope it helps some of you all out. So thanks for visiting Vermont. Hope you have a great day, and if this helps, leave a comment. Appreciate to see what kind of situation you're dealing with at your house. Have a great day. Thanks.
The grass is always greener in Vermont, and the sun shines just a little brighter too. And when the moon shines on the mountainside at night, You just know the Vermont way of life is right.